the Wilcoxon rank sum test. Till now, in my previous video, I explained Wilcoxon's science rank test, but this is Wilcoxon rank sum test. So Wilcoxon rank sum test is a non-parametric test. To refresh your memory, non-parametric test we use when we don't have requirement and we don't know what kind of population it is. It's not a normal distribution. Then we can use non-parametric test and can be used to determine whether two independent samples were selected from population having the same distribution. So what are the requirements for the Wilcoxon rank sum test? First of all, both must be at least 10. Okay, let me highlight on this important stuff so you can take a note if you want. The samples have to be independent. Oops. Okay. Samples have to be independent. They have to be, both samples have to be at least 10, so more than 10. And between two samples, we are going to work the one that has smaller sample size. Okay? When calculating sum of ranks, here it is, we use ranks for smaller of two samples. Now, before I continue, I would like to bring to your attention the difference between Wilcoxon science rank test and Wilcoxon rank sum test. So the science rank test is for dependent samples, for paired samples. That is non-parametric. While Wilcoxon rank sum test is for independent samples. Okay? This is a difference between them. Okay, so next we are going to explore the test statistics for the Wilcoxon rank sum test, the formula for it. Wilcoxon rank sum test. Given two independent samples, the test statistic Z is going to be equal R minus mu R divided by sigma R. R is a sum of the ranks. We will learn how to calculate. Mu R, it's an average for these ranks. It's going to be calculated this formula, using this formula, and standard deviation is going to be calculated through this formula. Okay? Next. We are going to follow the guidelines. What do we need to do to solve Wilcoxon rank sum test? All right. So first one, we need to make sure that they are independent samples. Okay. Then identifying claims. So this time I decided to go over, maybe it will help you better. We identify the claim. Then we specify the level of significance, which is alpha. Okay. And determine the critical values I am going to place under this video. I'll write down, find the table in the comments, pinned. Okay? All right. So once we determine critical values, we determine finding the sum of ranks for smaller sample, which is going to be our R. All right. Next, we are going to list the combined data in ascending order. So we're gonna mix up both samples and write down in the ascending orders. Okay, and after that, we are going to add the sum of ranks. Whatever rank is it, we are going to add the sum of smaller sample and 1. Okay. Calculate the test statistics through this formula and make decision. If Z in the rejection region, we reject null hypothesis. If it's a fail to reject reason, then we fail to reject null hypothesis. And do interpretation of the given claim. Okay, so let's solve this problem. So this table shows the earning in thousands of dollars of a random sample of 10 males and 12 females. Okay. At alpha equals 0.1, can you conclude that there is a difference between males and females? Okay, so what is our claim? It's to find out if there is difference. If difference, that means in null hypothesis is going to be no difference. And alternative is going to be yes, difference. Okay, so now our claim is there is a difference, which is this one is going to be our claim, null hypothesis. Okay, all right. So because the test is two-tailed, right, equal not equal, alpha is equal 10, then the critical values are gonna be you're gonna split and get 0.05. Here it is. So based on alpha half, it's gonna be 0.1 divided by 2. We get 0.05. And in the z-score table, we're gonna find out that it's at negative 1 point, plus minus, okay, let's put both ways. So z critical, it's going to be plus minus 1.645. And obviously you are going to look 0.05 in the negative, let's say 0.05 in the negative z-score table, where you will discover negative 1.6 here will be between 0.04 and 0.05. That's why we say 1.645. Okay, so the rejection region is going to be this area greater than positive and less than negative 1, right? I painted in green color. All right. So we have our critical value. Let's moving on. So next we need to find, since here is kind of made a mess, let me rewrite the proper way. So it's gonna be, oops, mu r and sigma r. We need to find out. Okay, so the sample size for men is 10, and sample size for N1, let's say, is 10, and N2 is 12. This is male, this is female. Okay, so before we calculate test statistics, we need to find the values of R, mu R, and sigma R, because all these three are going to participate in the calculating the test statistics. So here the table we have combined data listing in ascending order and corresponding ranks. So there are both samples here, 77 all the way through 117, and mark down rank 1, 2, 3, 4. Since here we have 2 of 85s, no, I'm sorry, 86. 86, 86, so 5, 6, they put the average 5 and 5, 5 and 5, and so on. 93, 93, so 10, 11, they put 10 and a half, 10 and a half, and so forth. Okay, so because the smaller sample is the sample of male, the R sum is going to be, so from here we are going to choose, let me see, I need some lighter one. Let me take it from here. Okay, we need to choose, since male is a smaller size than female, we're gonna choose the ranks of all males. This one, and this one, this, there, this. Oops, it's highlight on female. So all males you choose and add up their ranks. This one, two, this here is 2, and then 5 and 5, and so on. You are going to add all ranks, and as a result, we are going to get 2 plus 5.5, 10.5, blah, 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 and R is equal 138. Next, since our N1 is 10, N2 is 12, we are going to find mu R, and this one is, I will scratch, we need to find mu R and sigma R, because some reason it doesn't establish the proper notation. So the formula for mu R is, here you have it, but I'll just rewrite it. N1 times N1 plus N2 plus 1 over 2. And Y2, 2 samples, and sigma R is equals to N1, N2 times N1 plus N2 plus 1 over 2, right? No, 12, I'm sorry. Because we have total, the sample for female, we have here 12, bigger size, okay? And we take square root. There we go. So, R we calculated is 138. Correct? Mu R we calculated 115. And sigma R we have 15.17. So there is nothing else to do, just plug the values to the test statistics. Oh, here it is. 138 minus 115 divided by 15.17, and we have test statistic 1.52. So 1.52, and which means it's falling in this area, right? Which means we fail to reject null hypothesis, and since our claim is alternative, then we reject alternative, because that's our claim. So we need to do interpretation regarding rejection of alternative. Alternative is working always with verbiage support. So how to build the meaning reject with the word support? Following way. There is no enough evidence to conclude that there is difference. So there is not enough evidence to support null hypothesis, or not enough evidence to conclude that there is a difference between the males and females' earnings. Okay? And that's it. So again, we are using Wilcoxon. We are using Wilcoxon signed rank test. This is from somewhere else. Signed rank test to determine if two dependent samples are selected from population having the same distribution. Using Wilcoxon rank sum test, that's exactly what I was telling you at the very beginning of recording. We need to determine if two independent samples, let me highlight on this. Independent here and the dependent here, okay, are selected from population having the same distribution. Okay, this is all about Wilcoxon rank sum test. You know how to test it, and I will move to next video.